Today's lesson is 9.1, Characteristics of Polynomials. Let's go ahead and start with the definition of a polynomial. This is an expression that can have constants, variables, and exponents, but there is no division by a variable. There is only whole number exponents, and it can't have an infinite number of terms. Some characteristics that we're going to talk about today are that polynomials are named by their degree and the number of terms that they have. We're going to talk a lot in this unit about standard form. This is when my exponents are in descending order, that is from the largest to the smallest. Here is an example of a polynomial. Notice that we have a constant, we have variables, and we have exponents. These are some non-examples. Here is the example of division by a variable. This is not a polynomial. You have to have whole number exponents. This is not a whole number exponent. In fact, I could rewrite this. I could rewrite this expression, sorry, it's not a polynomial, as 5 times the square root of x, because the exponent of 1/2 is the square root. And down here, the reason this one is not a polynomial is because, once again, I do not have a whole number for the exponent. I have a negative. Infinite number of terms would be like, say, there's a minus here and then it goes dot, dot, dot. And so it means that it's continuing on in a pattern forever. That would be infinite. All right, before we go ahead and talk about the characteristics today, we do need to talk about the laws of exponents because we will be seeing them in this unit. Here are some of the laws of exponents. The product of powers, when you have two exponents that are being multiplied together, you can go ahead and add the bases, add the exponents. Now you can only do this if the base is the same. If the bases are different, you cannot do this. When you are dividing two exponents with the same base, you can subtract the exponents, always the numerator minus the denominator. This is the quotient of powers. The power of a power, or when I am raising a power to a power, I'm going to multiply the powers. The power of a product, notice that the power is outside and the two expressions are inside. I'm going to distribute that power to both of them, and it's going to be x to the m times y to the m. Likewise, when I have a quotient and there's a power outside, the power is going to get distributed to the numerator and to the denominator, giving me this. When I have a base being raised to a negative exponent, it gets changed into this. Now, of course, the n's going to go to the numerator and the n's going to go to the denominator. 1 to the n is just going to be 1. Likewise, when I have this, what's going to happen is my y and x are going to flip and my power will become positive. The identity says any base to the power of 1 equals that base, and any base to the power of 0 is the numerator 1. All right, let's go ahead and take a look at some of the problems that you will see in your assignment today. So notice with example A, I see the power of a product. So I'm going to take that exponent and I'm going to distribute it to each one of the terms inside, each one of the parts of the term inside. So I'm going to say 5 to the third power, u to the 2, and remember when I have a power to a power, I'm multiplying the power times the 3 that I'm bringing inside, times v, it already is 4 times the 3 from the distributing. 5 to the third power, if I put that into Desmos or into the calculator that Alex will provide for you will be 125. 2 times 3 is 6, and 4 times 3 is 12. Since U and V are different letters, that makes them different bases, and there's nothing more I can do. So that's my final answer. Let's go ahead and take a look at B. Now notice in B, I see the same thing for the first term. I'm going to have to distribute this 2. And once I get to the variables, to the letters, I'm going to be multiplying the exponent that is there times 2. And then for the second one, I am just simply multiplying. So here we go. I have negative 2 to negative 2 squared. I'm going to go ahead and put that negative 2 inside because it was inside already and it will make a difference. Whenever there's a negative number you are going to square it or cube it or raise it to the 4th power, you need to make sure that you keep it in parentheses. All right, so then it's going to be 3 times 2 for x. For y, it's going to be 3 times 2 as well. And for z, inside there's a 1, and I'm going to multiply it by 2. I'm going to go ahead and just break down the second one. There we go. I just did it without the parentheses. Now what I have to do is I have to get my like terms together. I have to get my like terms together. But before I do that, let's go ahead and say that this is, hold on a second. Okay, I made a mistake in my notes. Hold on. There we go. This is going to be 4. Negative 2 times negative 2 is 4. 3 times 2 is 6. 3 times 2 is 6. 1 times 2 is 2. And I'm just going to copy. There we go. Now I'm going to go ahead and I'm going to put together like terms. That means the constant with the constant. So I'm going to go ahead and I'm going to multiply 4 times 3. Then I'm going to put the x with the other x. Let me grab another color here. I'm going to put the y with the other y. There is no other y. Okay. And lastly, let me grab one more color. There we go. I'm going to put the z with the z. Okay, so remember that the rule says up above, when you are multiplying powers, it's the product of powers at the top. We're going to go ahead and we're going to add together. So I'm going to add the 2 plus 2. I'm going to add 6 plus 2, and I'm going to multiply 4 times 3. So 4 times 3 is 12. X, 6 plus 2 is 8. Y stays y to the 6 because it didn't have anybody to add to. And z is going to be 2 plus 2 to the 4th power. There we go. All right, and for the last one, for C, we're going to go ahead and we're going to put together our like terms. It's already done. There's no distributing of a power. I'm just going to go ahead and say I'm going to take the 36 and divide it by 9. So the first thing I'm going to do is say 36 divided by 9. What is that? Okay. Then I'm going to take my x's and the quotient rule over here, the quotient rule right here says that I'm going to subtract the numerator minus the denominator's power. Well, the denominator doesn't have a power, so it's going to be 1. Then I'm going to do the same thing for the y's, the numerator minus the denominator. And I can make those in color if I needed to, right? Because I had them right here. Let me bring my blue back. All right. So 36 divided by 9, 36 divided by 9 is 4. 4 minus 1 is 3. And 3 minus 1 is 2. There is my final answer. That's it. Now, if you did end up with a negative, just in case, because when you do subtract, sometimes you do end up with a negative. So when you subtract, don't forget that when you get a negative, then that exponent needs to go to the denominator of your fraction and become positive. But it shouldn't happen. All right, let's go ahead and take a look at how we classify polynomials. How do we name them so that we all know we're talking about the same polynomial? Well, we name them in two ways. We name them by their degree and we name them by their number of terms. When we are naming them by degree, we're looking for the little exponents that are popping up with the variable x or y or w or whatever letter it is that they're using. When you do not have a variable, what we have is a constant. It is called a constant, and it can look something like this, just the number 3. When we have something that looks like this, we call it linear. Because notice my x, its exponent is 1. When I have something that looks like this, it's called quadratic. Because my highest exponent is 2, which I know is a parabola, which is a quadratic function. When my function looks something like this is called a cubic. And we've already talked about the cubic functions. That's because my exponent is 3, or the highest one that I have is 3. When I have something that looks like this, y to the 4th minus y squared, this is called a quartic because the highest exponent is 4. And when I have something that looks like this, y to the 5th plus y to the 3rd plus y, this is called a quintic polynomial. Anything after this is simply called by its degree. So let's take a look at 6. Let's say we have a 6. Let's say we have something like x to the 6th plus x to the 4th plus 11. Because my highest exponent is 6, I would call this a 6th degree polynomial. When my highest exponent is 7, I call it a 7th degree. When it's 8, I call it an 8th degree, and so on and so on. They only have special names up to the exponent of 5, and then afterwards they just get named by their highest exponent. All right, there are only 3 special names by the number of terms. So let's go ahead and get started. When you only have one term, something like this, you are going to call it a monomial. Yes. Mono meaning one, okay? When you have 2 terms, like x squared plus 2, 2 terms, 1, 2, you call it a binomial. So bi for 2. When you have 3 terms, something like this, you call it a trinomial. And then we stop. And then we stop. Anything with 4 or more terms, so let's just go ahead and say 4. There's 4 terms like so. I will simply call it a polynomial. Okay? It could have 5 terms, 6 terms, 10 terms. I'm going to call it a polynomial. 1, 2, and 3 get special names. Anything after that is a polynomial. All right, let's go ahead and take a look at some examples of naming, but before we name them, we have to make sure that they are in standard form. To be in standard form, my terms must be arranged by degree in descending numerical order. That means the biggest one has to be first, and then we have to count down in order. So notice like here, I had 5 first, then I would have to put 4, but I didn't have one, 3, then 2, but I didn't have one, 1, and then none, but I didn't have one. So I can skip, it's okay to skip, but I have to put them in order. So it'd have to be 5, 4, 3, 2, 1, none. Okay? It would have to be 2, 1, none. 1, none. This one should be 3, 2, 1, none. Okay? Standard form. So let's, oops, oh, what happened? There we go. Let's go ahead and take a look at our examples. We must write each polynomial in standard form first, and then we're going to go ahead and classify it by its degree and its number of terms. All right, so if I look at example 1, it is not in standard form because the variable is not first. So I'm going to go ahead and rewrite it in standard form. And I'm going to go ahead and call this a linear because my degree is 1. My degree of my variable is 1. And it has 1, 2 terms. So I'm going to go ahead and call it a linear binomial. All right, let's take a look at the next one. I always start with standard form by finding the biggest exponent, which would be the 2 in this case. And then we're just going to put it in order. 2, and then 1x, and then no x. So there's my standard form. It is a 2, so it would be a quadratic. And there are 3 terms, 1, 2, 3. So I'm going to go ahead and call this a trinomial. Now, question number 3, it is already in standard form because it only has 1 term. Since it only has since its highest degree is 5, I'm going to go ahead and call it a quintic. And it only has 1, so it's going to be a monomial. All right, let's take a look at number 4. The largest term is the x to the 4th, so I'm going to grab the negative 6 with it. Then I'm going to do the 2 because it's 4, 3, 2, and then 1, and then none. There we go, there's standard form. My highest variable is 4, so that's going to be a quartic. And there are 1, 2, 3 terms, so this is a trinomial. Question number 5 is in standard form already because there's only 1 term. Its variable has the exponent of 3, so it is a cubic. And since it only has 1 term, it is a cubic monomial. All right, number 6, the exponent needs to go first in standard form, and then it would go 2x squared, x, and then just the plus 1. The highest term is 3. The highest exponent is 3, so this is a cubic. And there are 2 terms, 1, 2, and so this is a binomial. All right, the last row. Number 7. It almost looked like it was in standard form, but 5 is bigger than 4, so I do need to make that change. There we go. The biggest one is 5, so this is a quintic. And there are 3, so this is a quintic trinomial. All right, number 8 almost looks like it is in standard form as well, but squared is bigger than x. Squared would be a quadratic. Oops. And there's 2 terms, so this would be a quadratic binomial. All right, now this last one, they are like terms. So I am going to go ahead and subtract them. And so my standard form would be negative 4x. x, because they are like terms. There's only one term, so this is a monomial, and the largest exponent is 1, so this is a linear monomial.